I just want to move on to one other example, and this is one that we'll elaborate on further as we go on in the course, of detecting statistically significant differences in medians. So this is an updated version of the chart that was in test 2. This is the chart that shows. So this is a run chart of new COVID cases in the Canberra region since the current lockdown began. And you'll recall, I'm sure, from the test that we had this grey dashed line here in the background there. That's the actual daily number of new cases, and then we had a running median, which is superimposed as this blue solid line. So this is I updated this this afternoon, so it's got the latest result in it, which is 7 cases. I don't really want to talk about the running median. What I want to explain is that is what I've done here. So you'll see I put 2 vertical lines here. So this is the vertical lines show what I've chosen as my baseline data. So using that baseline data, so that's the data that's starting there on the 17th of August, and it goes through till the September the 4th. I've chosen that because that seemed to be sort of fairly representative of, where things were sort of beginning to look stable in the pandemic. And I used that to calculate an upper fence. So that's that red dashed line across the top there, horizontal line. And I've also put in a solid green line here, which is the median of that baseline data. And so what we do in a run chart, this is what we normally do in a run chart, is we identify a baseline where we think things are reasonably stable, reasonably sort of looking like could be in statistical control, and then we look to see what happens afterwards. Okay, so this is now looking at what happens afterwards. So we've got, I think, about 16 data points here, and if you look at it, what you'll see is it's sort of bouncing up and down around the median. And what the running median is doing with that is it's smoothing it basically. And for the last, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days, the running median is just a straight line. So if we're interpreting running medians, I would interpret that, and the Chief Medical Officer of the ACT has interpreted that. Indeed, has even interpreted this earlier data as the case numbers plateauing, as kind of leveling. The question we're interested in, is there a trend? Okay, is there an upward trend or a downward trend? And that's obviously a very important question. There are many situations in business where we want to know the answer to a question about a trend, and we can use this technique. We can use a run chart, we can set up a baseline, and then we can track it. But to determine whether there's a trend, and we can think of a trend in this situation as a shift. So the trend would be indicated by a shift, a statistically significant shift in the median, up or down. So one way we can do that is we could get the data and we could draw box plots for the baseline and box plots for the current situation and compare them. We could do that. Another way, or we could do a statistical test like a t-test or something, but there is a technique that we can use just using the diagram, and this is the technique I'm talking about. It's the details will be the subject of another lecture, but I'll just tell you what we look for, because this is a refinement of a technique that's been around for a long time, and the refinement emerged around about, I think it was about 10 years ago, and it emerged in hospitals in the European Union, and initially I think in the Netherlands. And the sorts of run charts we're talking about are run charts for adverse patient incidents, for things going wrong. So what we look for here is there's two tests that we can apply. So the first one is something that's called a shift test or a run test. And what we're looking for is something called runs. So a run is where you have two or more data points that are successively above or below the median. So you can see there we've got a run of 2. Okay. And here we have a run of 2. I'll ignore the runs of 1, okay? So I've got a run of 1 there and a run of 1 there. We've got a run of 3 there. And then we've got a run of 2. And that's a run of 1, and that's very nearly an outlier. And there was an explanation for that, which I've forgotten. It was probably a illegal party or a construction site or something, I can't remember. Or it might have been a school, I don't know. So that's 1, and that's 1. So the biggest run we've got there is 3. Now, to identify a statistically significant shift in the median, we would need a run of 8 or more points in a row. That's the test. Now, the actual number that you look for, so in this case 8, that's determined by how many points are in this data set. So if it was a much longer period of time with many more data points, it would be an even longer run that we would look for. So that's one test, is the runs test. And then there's a different test we can also apply, and these tests are kind of independent. Either one will tell you that there's a significant shift. So the other one is called a crossings test. So what we look for with crossings tests is how many times the data crosses the line. So it crosses once there, it crosses there, and there, and there, and there, and there, there, and there, and there. I think I've got all of them. So we've got 1, 2, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got about 10 crossings. We would need, for 16 data points, I think we would need 3 or fewer crossings to detect, to show us that there was a statistically significant shift in the median. Okay, so if either one of those tests gives us a positive result, then we have a statistically significant shift. And that means if there's a statistically significant shift, that means that the process is out of control, out of statistical control. Now that can be a good thing. In this case, if it's going down, if it's a statistically significant shift going downwards, that's a good thing. We want that. We don't want it going upwards, and particularly not with a pandemic, because the pandemic process is one which very quickly gets out of control. Once it starts getting out of control, it goes crazy, as we have seen. Whereas in the other direction, it tends to take its time. But there are many situations in business and organizational life where run charts like this can be very useful. And the great advantage of them is that, you know, if you're working in a team and there's something you want to track like this, you can just put this up on the wall, and you can, people can just look at it and do the counting and do the check, and they can see whether whatever it is that they're trying to improve, for example, is actually improving. So that's the final test that I'm going to be teaching in this course about differences of medians, but a very useful one. So Sarah, yeah.
Sorry, but going back to what you were saying before with like the comparing the two medians,
Yeah.
can you apply that to this statistical control thing, like for this?
Yeah, sure. So one way of doing it, let me do an actual example, if I can. Just give me a second. I have one I prepared earlier. Okay, so this is the COVID case data. So that's the actual data I use to prepare the chart. So it's got the new cases and the running median and the dates. And then I've split it up and I put it into a little table like that. Okay. So you've got the baseline there, and then you've got the new cases after the baseline. So what I'm going to do is I highlight that, I'm going to copy it, and then I go here, a familiar little web page, and I'm going to paste in the data, and I will tell it that it's tab separated, and hopefully that will do the thing it's supposed to do. Now, this is where things might get a little bit interesting. I'm going to add the notches. So hopefully, if I scroll down, let's make them horizontal. Okay. So there's our box plots with the notches. Now, you'll see with the new cases that the box is kind of folded in on itself a bit. And what's going on there is the vertical line on the box, that's the actual edge of the box. But the notch is wider than it extends beyond the box. Okay, so that will happen sometimes. It often happens when the data set's not very big. So the actual box plot box goes up to there. Oops, actually it's not, sorry, I can't draw on that, but so the actual box plot box goes from there to there, and the notch goes a bit beyond. But when you look at that, you can see the boxes overlap substantially. So using that test, we can't draw any conclusion about there being a statistically significant difference in the medians. Okay. Does that help? That's kind of directly comparing the two, the baseline and the new cases. So the situation we're in Canberra with new COVID cases is that there's no statistically significant movement up or down. Okay. What we're of course hoping, you know, what we all hope is that this one here down here will turn into a run of, you know, at least 8 or 9 or 10 that are below the old median. And in that case, we'll be able to conclude that there's a statistically significant shift. Did that make sense, Sarah?
Yes, it does. Thank you.
Right, you're welcome. Okay. So any other questions, folks? Oh, good. Okay. So next week, we'll continue this. Next week we're going to look at proportions, and we don't use box plots with proportions, but we do have some formulas, and they are a little bit more complicated looking than the one we've used for medians, but I don't think they're too bad. And once we're done with medians and proportions, you've got the equipment you need to use, or you could use, to analyze the most common experimental designs. And it's experimental designs that we really use to try and establish cause and effect relationships, and that's what the lecturers in week 8 and 9 in particular are going to focus on. So this is sort of preparation for that. This is like this week and next week we're covering the toolkit, if you like, for experimental procedures. So thank you, everybody, and I'll be around for a while to take questions.
Hi, Ed. I just have a question. So would you be teaching us t-test in this course?
No.
Oh, no. So, okay.
No, I won't. I mean, look, I suppose I could do video or something where I show you how to do one in Excel. But the the problem is to teach it properly. I'd have to explain all about normal distributions and standard deviations and so on. I mean, if you already know those things, it's not very hard to learn how to do a t-test. And the t-test has some advantages in some situations. So if your data meets the requirements, so roughly normally distributed, no outliers, you can do a t-test with very small samples. It can work with a sample of, I don't know, even 5 or 6. Okay, so it can be a very useful test. But the reason I haven't done it is I'd really, to do it properly, I'd have to spend at least like a whole lecture on it.
Okay.
Yeah, but I think, I mean, there are so many resources on the internet now explaining those things. So if you want to learn how to do it, it's pretty easy to find out.
Okay, sure. So we wouldn't be tested on any of those.
Nothing to do with t-test. No,
Okay.
I'm not going to mention it in the test. It's just the reason I'm doing it is just I know that there are quite a few students in the class that have already done a statistics course,